Here's the answer I came up with. The actor wants to maximize the number of burned calories, and he burns 12 calories for every minute of step aerobics and 4 for every minute of stretching. He can't spend more than 40 minutes total, so I express that constraint by saying that x plus y is at most 40. And expressing that he has to spend 5 minutes stretching is a little unintuitive because of the way the inequality is directed here, but I can do it by saying that negative y is at most negative 5, like so. Using the graph and check method of your high school teacher gives the optimum solution as 35 minutes of step aerobics and 5 minutes of stretching. Now, you probably didn't bother graphing the polytope as I've done here. The answer was too obvious. But why was it so obvious? Maybe you realized that more exercise was better and started thinking about constraints somewhere along here that used up all 40 minutes. Because step aerobics burn more calories, you realized that you would want to do as many of them as possible, pulling you along this constraint downward towards this vertex. Or maybe you realized that just 5 minutes of stretching and 0 minutes of step aerobics would satisfy the constraints, and then you decided to increase the number of minutes spent on step aerobics until you ran into another constraint. In either case, your intuition led you to think very much along the lines of the simplex method that we'll see in a little bit.